Hi there, today I'm going to show you an interactive way to do machine learning. And this is very useful if you want to learn machine learning in a very easy way, in a very rapid way. So you can go to my platform datajarvis.ai and you can access this machine learning lab. Now, once you launch this application, you will see that you can do all the steps of machine learning right from uploading the data all the way to coding as well as analyzing the results in a very interactive way. But first, let us start by uploading some data. So the data set which I've selected here is based on a problem related to telecommunication churn prediction. So telecommunication companies, they are interested to know if a customer is going to leave or not. And this is important for them because if they know, if they can predict a customer churn, they can take actions to avoid it. So here we have two data sets. One is the training data set and other is the test data set. So training data set can be used to train a machine learning model which can predict if a customer is going to leave. And then this model then can be tested on the test data set. Now, let us now do the second step of feature selection and target selection. So here the target is our churn column. Right? This is what we want to predict. And this machine learning is of classification type, which means that in this target column, there are only two values. Either the customer is with the company or customer has left. So we are trying to predict those two values, which is a classification kind of problem. We also need to select all the different features, means all these features are going to be used to predict if a customer is going to leave or not. So I'm going to select all of them except for the customer ID. And let us now confirm the selection and let us now go to the next step, which is related to the data exploration. So here you see some summary statistic. So you see that the data set has got 7,032 rows as well as it has got 21 columns. And here you see some column statistic. Now you can see here that the columns can be of numerical or categorical. So numerical means they are values, numerical values. So for example, tenure means how many months the customer is with the company. And here you can see that minimum is 0 and maximum is 72 months. And you can see that the columns such as gender is categorical, which means this is non-numerical values and these values could be male and female. Now, once we have done that, we can now go to the next step, which is related to configuring the machine learning pipeline. So here we need to do some data preparation, and one of the first data preparation is to handle missing values. Now in the data set we do not have missing values, so we do not need any specific action over here. But when it comes to scaling, we need to configure some steps. So let me explain you what is this. So you saw earlier that you have columns, you have numerical columns such as total payment or for example tenure, and both these are in different scale. So for example, tenure is in number of months and the total charges is in dollars. So you need to scale them so that both of them are at same scale, and this you can do using the standard scaler. Now machine learning models, they do not work with categorical data such as gender. If you're male or female, it's not going to work. So you need to also one hot encode them. It means convert male into 1 and female into 0, and this you can do it using one hot encoding. You also need to do a test split, which means that out of the training data, the model is going to take some data for training purposes and then it is going to self-test it on the test data. So here we can specify a split. And here I have put a split of 20%. So 20%, 80% of the data will be taken for training purposes and 20% of data will be taken for test purposes. So feature engineering, we do not need specific feature engineering for the moment. And model selection, there are various ways to train a machine learning model, and let us go ahead and select the random forest one, which is pretty interesting. It is based on making decision trees, various decision trees, and then kind of combining all the decision trees. And it's for this reason this is also called as collection of trees. So it is also called as forest, random forest. So let us go ahead and select all these parameters, and now the application is going to generate the Python code. So it is going to look into all the different ways in which what we have done the setting, and based on that it is going to come out with this Python code. So this is interesting because you know that what are the different settings we have made, and then you can try to see if those settings, how they are reflected in the Python code. So let me kind of briefly go through this code. So you start with importing some packages over here, and then as we have seen, you can set the target columns and the feature columns. And then here, as you have seen, that we are setting the target column as John. And then you can also make this X and Y. You split the data into the target and features. You need to one hot encode them. So here we are first of all selecting only the numerical values, as well as you also need to prepare a numerical transformer. So this transformer is basically just applying the standard scalar, as well as you also need to apply a categorical transformer to all the categorical columns. And then you make a preprocessor which has got both the categorical transformer as well as numerical transformer. And then you make this machine learning pipeline which has got all the pre-processing steps, which is this one hot encoding as well as standard scaling. And then you also apply your machine learning model. In our case, we have selected which is the random forest classifier. And as we have also set that we are going to use 20% of data to test and 80% to train, you can make this train and test split. Now once that's done, you can do a model training, which is this particular method called as fit. And once that is done, you can predict based on the test data. And here you will have your predictions, and then you can compare the accuracy. You can compare the predicted values as well as you can compare it with the actual values which are available in the data. And then you just print out all the different matrices. So let us now execute this and see on what results we get. So this is a results. You can see that we have an accuracy of 78%. You also have different values such as precision, recall, F1 score. So this is pretty interesting. So F1 score here is very important because what we want to do is we want to predict the churn, right? So it's important to predict who is going to leave rather than predicting who is going to stay. So this F1 score helps us to see on how good we are in predicting the churn. And here you can see that you also have the history. So before this, I've also executed different algorithms in a different way, and you can see how your accuracy changes based on different settings. So this interactive way is a very good way in which you can actually see on what are the different settings which are required for your machine learning model, how they are reflected in the Python code, and then you can execute the Python code to see the impact of your different parameters. A nice way of learning, and you can also try it out. Let me know your feedback. Thank you.